I'd like to introduce an important technique as part of solving quadratic equations, and let's look at this problem. I'm going to solve x squared equals to 25. Now you can just look at that problem and I'm sure you can immediately see that the answer is x equals 5 because 5 squared is 25. But there's another answer, isn't there? Negative 5, when you square that number, also gives you positive 25. So there really are two answers here, 5 and negative 5. Now we could get those answers methodically by factoring. So if I subtract 25 from both sides, it equals to 0. And we're able to factor the left side. This difference of squares gets split up into a product of conjugates. Remember the word conjugate from the complex number section. And this product of numbers equals to 0, so we can set each factor equal to 0 and solve. X plus 5 equals to 0, x minus 5 equals to 0. So here when I subtract 5 from both sides, I get a negative 5. Here I add 5 to both sides and I get positive 5. So there's how we could display a technique for finding both answers. But this seems to be a bit of work. And so why not take advantage of the square root? So let's remember now that you've got two answers here. I'm going to go back to the beginning, and I want to, for reasons that'll be apparent in a minute, I want to put a little space here between the equal sign and the 25. All right. I'm going to take the square root of both sides. So make each side, fit each side inside a square root symbol. Now that should be okay, right? Because we're doing the same operation to both sides of the equation. So what is the square root of x squared? It is x. And the square root of 25 is 5. So there's an immediate shortcoming to this method because it didn't give us the other answer, negative 5. Well, there's a pretty good reason for that. It's because actually the square root of x squared really is not equal to x. And not always, at least. It'd be more accurate to say that this is equal to the absolute value of x. I'll give you an example. If you took the square root of negative 6 parentheses squared. Alright, so negative 6 in parentheses is squared under the square root. Do I get negative 6? No, because negative 6 squared is positive 36, and then the square root of 36 is 6. And so, in other words, this is equal to the absolute value of negative 6, which is positive 6. Because recall that a square root is a function, and by definition its output is always a positive number, or it could be 0, but never a negative number. Alright, so this, technically speaking, the square root of x squared is actually an absolute value. And that takes care of getting a positive answer. So, but if you were to look at the absolute value of 5, I'm sorry, let me, if you looked at the absolute value of x equals to 5, then you'll see that there are two answers to this. The absolute value of 5 is 5, and the absolute value of negative 5 is also equal to 5. So it gives two answers. Well, rather than dance around all this absolute value business, our chosen way to fix this and these problems is to introduce the plus or minus symbol. So I'm going to put a plus or minus here. Now that's a plus sign with a little line underneath it. And so it represents two answers. X is equal to plus 5 or minus 5. So now we could, rewrite this as x equals -5, comma 5, represent two answers that way. So here's the kind of the summary of this. When you solve an equation by taking the square root of both sides, you actually are creating two separate answers, a positive answer and a negative answer. And to account for a positive and negative, we can accomplish that by putting a plus or minus symbol in there when we take the square root of both sides. It wouldn't matter if we put the plus or minus symbol on the left or the right, but since we're solving for x, it'd be logical to put it with the number. This, just mention this briefly, this idea of when you take the square root of both sides you get two answers is actually a general fact. If you were to solve this problem, x cubed equals to 1, by taking the cube root of both sides, you might say, well, there's only one answer. 1 to the third power is 1. So the cube root of x cubed is x is equal to the cube root of 1, which is 1. So there's our answer of 1. Well, actually, there are three answers to this problem. And so if you take a square root and you get two answers, then it may make some sense that when you take the cube root of both sides that you might get three answers. Matter of fact, let me write out the three answers. I'm not going to begin to show you how you get these, but you would study this in a trigonometry course if you take it. There's a lot of geometrical things going on here, but actually this problem has the following three answers. X is equal to 1, x is equal to minus 1 plus the I times the square root of 2, everything divided by 2, and it also equals to minus 1 minus I times the square root of 2 over 2. So you'll either have to take my word for it, or you could verify this if you take one of these two complex numbers and raise it to the third power and do all the rather nasty complex arithmetic on it. You will get positive 1 for an answer. So this notion of solving by using a radical sign introduces multiple answers, and but the main thing here is to learn about solving by taking the square root, the so-called square root method. All right, now let's get back down to earth, and I'll solve one or two more problems here for you by using the square root method.